Hello everyone, welcome to my channel. This is an educational channel and today is video number 258 on the reciprocal system of theory. And the reciprocal system of theory is a theory of everything, which is what we feature on this channel. And various theories of everything from around the world through the centuries. And the reciprocal system of theory is one of the shining examples of a theory of everything, in my opinion, and it was first discovered by Dewey B. Larson, and he lived from 1898 until 1990. But the last 60 years of his life was dedicated to working on the reciprocal system, especially the last 30 years after he put out his fundamental postulates in the late 1950s. The general idea is that we live in a universe of motion. The universe is not made out of matter, not made out of energy, but it is made out of motion. And motion is the relationship between space and time. So space and time are not the container of the universe. They are actually the contents of the universe. Everything in the universe is made out of space and time. Motion. Motion is a fraction whereby space or time is the numerator and time or space is the denominator. But time or space has a coordinate aspect, meaning that time and space both are 3 or more dimensions. Coordinate space, XYZ coordinates. And there's also coordinate time. And then there's also what Larson calls clock time and clock space. Clock time is that the clock is always getting later and later and later. Time is flowing or progressing. Same with space. Space is flowing or progressing. Space is always getting farther and farther and farther apart, which was observed by the Hubble telescope noting that all of the distant galaxies are moving away from each other, but in no particular direction. That is what Larson calls a scalar motion, a motion that has a magnitude, but it has no particular direction. Envisioned by taking a magic marker to a balloon and putting a bunch of dots on the balloon, blowing up the balloon, and all the dots are moving away from each other, but in no particular direction, or really every direction. That's a scalar motion. So this scalar motion describes the clock time and clock space. Also, space and time both come in only discrete units. There is a minimum unit of time and a minimum unit of space. Less than that, and you do not have that. So if you have less than 1 unit of space, you do not have space. If you have less than 1 unit of time, you do not have time. If you have 1 unit of space in 1 unit of time, space over time being motion, being speed, one of the many different kinds of motion, along with matter and energy and pressure and electric charge and electric current and capacitance and force and many, many others that are all representable by a fraction between with space or time as the numerator and time or space as the denominator, but in 1, 2, 3 or more dimensions. Speed is one just space over time. The car is moving 10 miles per hour. And if we have 1 unit of space in 1 unit of time, we have the speed of light. The speed of light is what Larson calls unit speed. 1/1 = 1. And at unit speed, that is what Larson says is the null point of the universe, or the 0 point, even though it's the unit. It's the midpoint of the universe. Half of the universe is moving faster than the speed of light, and half is moving slower. It's important to note that in a reciprocal system, as opposed to an additive system, 1 is the center, not 0. If you have an additive system, you have 0 at the center, and then you have +1, +2, +3, and on the negative side, you have -1, -2, -3. But in a reciprocal system where it's multiplicative, the center is 1. And then on the positive side, you have 2, 3, 4, and 5. And on the negative side, you have 1/2, 1/3, 1/4, and 1/5. So that is the major difference there. So anyway, in Larson's system, then half the universe is moving faster than the speed of light, and half is moving slower than the speed of light. It's what Larson calls the cosmic sector and the material sector, respectively. And this cosmic sector is something that the scientists know very, very little about. But we can learn about it because we can extrapolate from the material sector. Because of the reciprocal relationship, we know that what is going on in the cosmic sector is exactly the same as what's going on in the material sector, except that you have to reverse the roles of space and time. So that's basically how it works. You have 2 different sectors of the universe divided by the speed of light. And then these sectors these 2 sectors, the material and cosmic, are divided by what is called the unit boundary. The material sector has a small subsector that is called the time region, and the time region is everything that is less than 1 unit of space. If you don't have space, then you only have time. And so within 1 unit of space, you don't have space. You only have time. So Larson calls that the time region. In the cosmic sector, you have the opposite, where you have less than 1 unit of time. Then you don't have time. You only have space. And so Larson calls this the space region. And the time region and the space region, subsets of the 2 larger regions, or the 2 larger sectors, are the regions of, atomic and molecular activity. Now, Larson passed away in 1990 after leaving behind many books and articles, and he also had a little bit of a following. There was a journal called Reciprocity that published articles for many years and had a few dozen different published authors of articles. And one of them was Dr. Bruce Perret. And Dr. Perret did a great job of updating some of Larson's work, especially after he died, and to extend it into other areas. And we're looking at one of his articles today, actually the 4th article in his series called Anthropology, the Hidden Origins of Homo sapiens. So Perret uses Larson's work in many different ways. He has a wide range of different articles, but these particular articles take it into the area of, cryptohistory, geochronology, and also philosophy. So now we have gone through the first 3 of his articles in this series. So if you want to go back and listen to the videos for about the last month, you can get a gist of what Perret's talking about in those first 3 articles. But this fourth one, we will start now. It's called A Short Time Ago in a Galaxy Close, Close Nearby, Part 4, A New Hope. This is just the intro here. It is a period of scientific war. Rebel researchers working from a hidden basement have won their first victory against the evil world order. During the battle, rebel spies managed to steal secret plans to the order's ultimate disinformation campaign, modern astronomy, an armored system of theory with enough assumptions to destroy an entire postulate. Pursued by the order's sinister agents, the ghost of Lloyd Pye races home across the cosmic sector, custodian of the insider info that can save humanity and restore freedom to the galaxy. Daniel. And Daniel is the pen name, one of the pen names of Bruce Perret. Daniel Phoenix 3, this is a character that don't know whether it existed or not, but who claims to have worked on the Montauk Project in the 1980s, the top secret government time travel project located out on Long Island. You might have heard of Al Bielek or Duncan Cameron, and a few others have also, kind of blown the whistle on what was going on at Montauk. Okay, here is the introduction. Astronomy is backwards. Oh, this is a question. Astronomy is backwards? Ridiculous. Well, it seems the situation is a bit worse than even Dewey Larson realized when he presented this backwards model of stellar and galactic evolution in his book, Universe of Motion. This was discussed along with the planetary consequences thereof in my article, Geochronology, the first part of this series. Larson's model was based on conventional astronomical data, and the information presented in part 1 was a natural consequence of that data. But what if that data is wrong? Well, not exactly wrong, but viewed through a magnifying glass, making everything appear a lot bigger than it actually is, including the distances to other stars, the size of stars themselves, and most importantly, the size of galaxies. What if stars aren't light years away, but light weeks away? ET phone home is no longer a long distance call, just a shout out the window. This paper, part 4 of the Anthropology series on the hidden origins of Homo sapiens, is an analysis of the extraterrestrial influences that made this planet what it is today. The concept is known as intervention theory by the late Lloyd Pye, speculating that our world has not only been visited by other species and civilizations, but it was actually commonplace. And they appear to have lacked Star Trek's prime directive of non-interference. They got their fingers in everything. The primary objection to intervention theory was that habitable star systems were just too rare and distant for all these visitors to be coming to our world. Known as Tiamat in the ancient texts. But what if that was not the case? What if solar systems were common and close by, but just overlooked by astronomers and misinterpreted as something else? An accidental discovery was made by reciprocal system researchers while attempting to model the stellar neighborhood using Larson's concepts of progression and scalar motion. Now remember, we just talked about uh, the progression of space and the progression of time by scalar motion. It's a motion that has no direction. All of space is always getting farther and farther and farther apart, and time is always getting later and later and later. These are scalar motions and progressions. All the equations were checked, entered, the data loaded, and the simulation was programmed to show the night sky. But when the results came out, the sky was black, not a single star, except for the points of light representing the planets. Makes for a very lonely universe. No mistakes were found in the program code, but some debugging revealed the reason all the stars were outside the gravitational limit of our sun. The reciprocal system is based on discrete units of motion, quanta. When a net motion like the pull of gravity drops below one natural unit, it becomes zero and disappears. There are no fractional parts. In the reciprocal system, the reach of gravity is limited to that distance and no further. Gravity has no effect beyond this gravitational limit. Another consequence, documented by both Larson and Professor KVK Nehru of India, is that a three-dimensional coordinate system can only exist within the gravitational limit. Once you go past the gravitational limit, the progression takes over and the loss of dimension reduces space to equivalent space, a two-dimensional c squared, or speed of light squared, form of space that is analogous to hyperspace in science fiction. What made the stars disappear in the simulation was that the progression is a scalar expansion at the speed of light. And it got that label because the photons were being carried by this scalar expansion. So when we measure the speed of light, we are actually measuring the speed of the outward progression. The photons do not move relative to that progression. The light from the other stars could not cross the progressive void that existed between the gravitational limits of the stars, and the simulation determined that stars were out of the visible range and did not render them, resulting in the black sky. The planets, being inside the gravitational limit, did render as points of light, as did the sun. Attempts to understand and solve this problem led to the research of the late Barham Carteret's book, Revolution in Astronomy. Carteret, along with many amateur astronomers, wondered as to how we can see the light from objects so incredibly distant. To claim that the Andromeda Galaxy can be seen with the unaided eye some 2.5 million light years away is counterintuitive. Plain common sense says there is something wrong with this picture. We can barely see our own Milky Way galaxy through the light pollution of the sky. Can you imagine how bright Andromeda must be to be able to see it at that distance? Okay. just going over a few of his footnotes here to see if there's anything that I should let you know about. One is the progression, the scalar expansion of space, is actually recognized by conventional astronomers as the Hubble expansion. So we just talked about that. That's the Hubble telescope determined that all of the distant galaxies are moving away from each other. Okay, back to the text. Cadarai determined exactly how far a human being could see, with or without the aid of telescopes. He focused on the Hubble Space Telescope, concluding that its maximum range was a meager 357.14 light years. Recent upgrades, including digital imaging, may have increased that distance tenfold, but even 3,571.4 light years is still far short of ever being able to see galaxies that are millions or billions of light years away. That is, unless those galaxies are a lot closer than we think they are. That is the conclusion that both Cadarai and the recent reciprocal system research into the gravitational limit of stars has concluded. These galaxies far, far away are actually solar systems close nearby. And for those of us that remain uncommitted investigators and are able to actually consider this radically new concept and the estimated 100 billion galaxies, now also known as solar systems, within range of our existing 3,571 light-year telescopes, the implications are staggering. Larson is not infallible and took a shortcut in his astronomical research, using the data provided by the astronomers of the 1950s to base his stellar calculations upon, rather than attempting to derive stellar and galactic geometry directly from his physics of motion. Logically, his system works as explained. However, because he leaped from atomic data to stellar data in a single bound, he skipped over some important intermediary consequences that solve the puzzle of what it is that we actually see in the night sky. Larson's entire theory is based on the concept of scalar motion, and funnily enough, his mistake was one of scale. The original problem was this: the universe is constantly expanding. Gravitation is the inverse of that expansion, compression. This Hubble expansion wants to push everything apart at the speed of light, whereas gravitation wants to pull everything together at the speed of light. In a gravitationally bound system, there is a balance between the outward expansion and the inward compression, giving us our conventional 3D reference system. That would be, coordinate space. Beyond the gravitational limit, the outward expansion wins, hands down. Consider the case of an expanding balloon with spots on it. As the balloon expands, all the spots get further apart from all the others. This is scalar motion, a change in scale. If you add a spot in between, it still moves away from all the other spots and will never run into one. This is the case with photons and the space outside the gravitational limit. They are just new photon spots and are moving away from each other and all the stars. Light cannot cross that void. The way to fix the problem was to eliminate the expansion zones between stars, which meant reducing the observed distances between stars considerably. This begged the question of why these distances, originally measured through triangulation, were off by so much. The triangulation method was simple enough. Measure the angle between the sun and the star to be measured. wait 6 months until we were on the opposite side of the sun and take another measurement so you had a triangle with a known distance at the base, 2 astronomical units, or 186 million miles, and 2 angles to the sides. Later on, stellar parallax was used, which is a similar concept that measures the change relative to background stars that are assumed to be stationary, and those stars are actually behind the star you are trying to measure. This is how we obtained all our stellar and galactic distances. Now, I'm a little confused as to when he says our. Is he talking about the legacy scientist, or is he talking about his own studies? Another one of the footnotes, Larson did use his atomic physics to determine that stellar evolution and therefore galactic evolution was backwards. Because of the nature of the energy generation of stars, his redshift work on quasars and pulsars was also derived from atomic physics, since quasars were not even discovered until the 1960s, some 10 years later. Right, Larson predicted the existence and many of the qualities of quasars long before they were actually discovered by the legacy scientists. Okay, now let's see how long this section is. This section goes on for a little while longer. I think we're about out of time here, and we will resume here at the bottom of page 3 of this article starting tomorrow. So thanks for tuning in today, and have a beautiful day.